Good morning or good afternoon, everybody. This is 7.4 Part B. We're going to be doing inverses and horizontal line tests to prove that your inverse is a function or not. You can see we start with the definition here. Okay. Actually, you can see verify two functions are inverses, and we will do the horizontal line test to see if it's a function. So the two questions are right there. Here's our definition. We're going to recall this from before. If we do the composition f of g of x, and that equals to x, you know they are inverses. If you do g of f of x, and that also equals x, the function g is denoted by f to the negative 1, read as f inverse. Okay? They are inverses of one another. So that must hold true in order to be an inverse of one another. We have two questions here. Right? How can we use the two statements? Say, how could we use this statement to find out if two functions are inverses of each other? Literally just doing composition. So you're pretty much restating what that formula just said. That has to be true. And g of f of x also has to be equal to x. Both have to be true. To be inverse. To be inverses. Now, that still has nothing to do with functions. Okay. What is the easier way to do this? I usually like solving. I solve for the inverse of 1. With one equation, and then I compare it to the other. If they match, you know they're inverses. If they don't match, then they're not inverses. That's usually how I like doing it. I'll do it both ways though. Okay? So I'll do the first one in this definition, and I'll do the second one using this kind of idea. So if we do the first one using these compositions, so I'm going to rewrite, okay, let's call this f of x. I'll call this g of x. So I'll start with f of g of x. So g of x is on the inside, so that'd be x plus 7, which would be blank minus 7. I put x plus 7 in here. You can see I'm left with x. So the first one works. Let me switch it around. Now I'll have g of x minus 7. So blank plus 7. Put my x minus 7 in here. I get x. So this works. So yes, these are inverses of one another. That's using the definition at the top. If I go about it the other way, which is what I'm talking about here in the second one, this is y equals 2x minus 2. I switch x and y. I do x plus 2 equals 2y, and then I'll divide everything by 2. So that'll be 1y equals a half x plus 1. They definitely match. You can see this, they match. So yes, these are inverses again. So you can see I prefer the second one. First way, you can do it either way. Totally cool with it. All right, you're supporting your work with the correct solution. All right, so I'll do this one, do f of g of x here. Here I'll do g of f of x. So let's start with this one. So I put in the cube root of 2x plus 4. I'm going to go ahead. This is a half blank cubed minus 2. This would be cube root of 2x plus 4. Okay, so the cube and the cube root cancel out. Now I have a half times 2x plus 4 minus 2. Distribute. What's half of 2x? 1x. What's half of 4? 2. So that's just x. Let's go through my second scenario. So I have a half x cubed minus 2. I'm going to rewrite my cube root of 2 blank plus 4. This is where my half x cubed minus 2 goes. Distribute my half in, or my 2 in I should say. Half of 2 is 1, so this is x cubed minus 2 times 2 is 4. And then I have this plus 4 on the end. These cancel out. We have the cube root of x cubed, which is x. So yes, these are inverses. You can see that's a lot of work, okay, which is why I prefer to do this one. So what I'm going to do here is I'm going to switch x and y And then I'm going to solve this for y, get y by itself. So I subtract 6 over. Now I'm going to divide by 3. So this is 1/3 x minus 2 equals y. Do these two match? Nope. So this is no. Notice this has a negative. This is still positive. Okay, so that will not be an inverse. This has a negative. This does not. All right, so let's go ahead into the back. Okay, you can see, look at the graphs below. Two of the functions that are inverses, two do not. Okay. So let me zoom out here so I can keep the directions. How can we use the horizontal line test to determine if the inverse of these functions are also functions? Okay. All right. So the first one, they say yes, this will be the inverse will be a function. So that's why you do a horizontal line test. No matter where I draw the horizontal line, it will intersect once. So yes, the inverse would be a function. Okay. That's what they're getting you to make the conclusion. Technically, you don't have to write that. Whereas the second one is absolutely not, even though the original f of x is a function, because it passes the vertical line test. You can see me doing that with my marker. But the inverse will not be because it hits 2 times. So this one, the inverse is not a function. There is still an inverse, but the inverse is not a function. Okay, so this one's yes. The original is yes because it passes the vertical line test. It will also pass the vertical line test. It will always hit once. This here is really close. You have to be careful here. But this is still yes. The inverse is a function. Okay. This one is definitely not. The vertical line test passes, so the original is a function, but the inverse is not a function. Is not a function. All right. So the graphing part there was actually pretty straightforward. Now we're going to do, is the inverse of f also a function? We're going to use the horizontal line test. We're going to say yes or no. So first thing we need to do is let's solve for these inverses. Okay, so I'm going to switch my x and y, and then I'm going to get solved for my y by itself. So x minus square root equals negative 2y. Divided by negative 2, divided by negative 2. So we got negative half x plus 2 equals y. Okay, so is the inverse also a function? This would be yes, because this is a linear function. If you want to see the graph, by all means, it'll kind of look like this, where you'd have 1, 2, 1, 2. So you'd be down 1 over 2. Kind of look like this on a graph. Okay. So, yes. Is it a function? Yes. Does it pass the horizontal line test? Absolutely. All right, so go in here, switch x and y, and then I subtract 8 over y. So here's my inverse. Is this a function? Yes. Okay, if I graph that again, it's just a linear line. It will pass the vertical and horizontal line test. So if I graph the original now, last time I graphed the actual inverse and I checked the inverse using vertical line. 4, 5, 6, 7, 8. 1, 2, 3. So this has a slope of 1. So it would be 8, sorry, here, here. Kind of look like this. Passes the horizontal line, vertical line. Can use Desmos as well. All right, and that's what I'll do for the last 4. So what I'm going to do is I'm going to solve for these inverses. Switch x and y. This is x minus 3 equals y squared. And we take the square root of x minus 3 equals y. There's my inverse. This one's going to be no. This is not a function. The inverse. Okay. I'll show you that in a second. Let's switch x and y here. Got negative 1/3 y plus 6. So I'm going to subtract 6 over. And then I'm going to multiply both sides by negative 3. So that makes this positive y, negative 3x, plus 18. Okay, and this one's going to be yes. That will be a function. All right? Jumping down here, let's switch. So this is technically what I have right now. I'm going to switch that. So I'm going to divide by 4, have x over negative 4 equals y cubed. I'm then going to do the cube root. So y is equal to cube root of x over negative 4. Okay, I'm going to say yes for that one as well. Okay, let's finish up down here with this one. So this is y, right? So I'm going to switch x equals y to the 5th plus 3 over 6. So I'm going to multiply by 6. Have y to the 5th plus 3. I'm going to subtract 3, so I have 6x minus 3 equals y to the 5th. And then I'm going to do the 5th root of both sides. And this one we're going to look at. Okay, so let me get these punched in on Desmos. And we'll talk about functions, passing the horizontal line test, or vertical line test. Okay, so I punched in 7 through 10. Here's number 7. You can see it does not pass the horizontal line test, so this one would not have an inverse that's a function. Okay, let's go to the next one. We erase this. Okay. So here comes number 8. You can see this one passes the horizontal line test everywhere. So definitely a function. Right, let's jump to 9. Okay, this is really close. You can see the y values are always changing, so there's no horizontal line that will hit more than once. So this is a function as well. And then the last one. This one is even more nitpicky than 9. Okay? This looks like a horizontal line in itself, but watch my y values. Do my y values ever stay the same or get lower? And the answer is they're always changing. It's about as close as you could possibly get. Okay? Because remember, Desmos is rounding here. But that's pretty darn close. So I would have to say, yes, this is a function. It will pass the test. Because it's still getting larger, even though it's so slight, it's rounding it to 0.5. Okay? So that's pretty stinking close. It still passes the horizontal line test. All right, so let me flip back to our notes here. Okay, so here you go. There was 7, 8. And 9 and 10. Actually, I had it up here like this. Okay. So remember, this one was yes as well down here. So that one passed it. This one was yes. It was a function. This one was not a function. Yes, yes. Okay. Guys, if you have questions, please email me or see me. You know where I'm at. All right. Good luck, and I'll see you in class.